Curve sketching. الفيرست type translation. In translation we draw the same curve, but we slide the curve up or down, right or left. If we have function y equal fx and we draw this function, what about y equal fx plus 2? We add 2 to the function itself. So to draw this function from the original one, just draw the same curve, but move 2 units up. Move 2 units up. This means if you have point x and y, this point will be x and y plus 2. The y coordinates increase by 2. So we can represent this translation by this column vector 0 and 2. This means x unchanged, but the y increased by 2. So 0, 2 means move 2 units up for all units. Second type for translation, for example, y equal fx minus 3. In this case, because minus 3, so move 3 units down. Move 3 units down. So if you have point x and y, this point will be x and y minus 3. X and y minus 3. And we represent this translation by 0, negative 3. X unchanged, y decrease by 3. So for the first one, curve 2 units up. For the second one, curve 2 units down. But the same curve. But what about if we have y equal fx plus 1? Fx plus 1. In this case, we undo if we add 1, this means we move 1 unit to the left. Do the opposite. Plus 1, so 1 to the left. Minus 2, so 2 to the right. In this curve, if we have fx plus 1, this means move 1 unit to the left. This might plus, but we move 1 unit left. So if we have point x and y, this point will be x minus 1 and y. And we represent this translation by negative 1 and 3, negative 1 and 3. So minus 1 for each x, for every x, and y unchanged. What about if we have y equal fx minus 2? Fx minus 2. So the same curve for the function, the original function, but 2 units to the right. 2 units to the right. Move 2 units to the right. If you have point x and y, this will be x plus 2 and y. And we represent this translation by 2 and 0, because the x increased 2 and the y unchanged. Examples for translation. If we have the curve y equal root x, what about y equal root x plus 1? Root x plus 1. So move 1 unit up and draw the same curve. The point 1, 1 becomes 1 and 2. 4 and 2 becomes 4 and 3. So the y increased by 1 and the x the same value. The original function the same. Y equal root x. What about y equal root x minus 2? 2 units down. يبقى move down 2 units down. So minus 2 move 2 units down and draw the same curve. The point 1, 1 becomes 1 and negative 1. So the y decreased by 2. The y decreased by 2, but the x is the same. 1, 1 becomes 1 and negative 1. We represent this translation by 0, negative 2. The same if we have y equal root x, but we need y equal root x plus 2. This fx plus 2. Fx plus 2 we undo the operation. So f plus 2, so move 2 units to the left and draw the same curve. 2 units to the left, because this plus 2, 2 units left, and draw the same curve. Now look for this point 1 and 1 becomes negative 1 and 1. So it decreased x by 2. Because x plus 2 decreases. We represent this one by negative 2, this translation by negative 2, 0. Negative 2, 0. So if you have fx plus 2, this means it draws the same curve for the original function, but 2 units to the left. If we have root or fx, if we have fx minus 3. We have the original function y equal root x. So what about y equal root x minus 3? Root x minus 3, so 3 units to the right. 3 units to the right. So 1, 2, 3. So draw the same curve. Point 1 and 1 becomes 4 and 1. So add 3 for x. So we represent this translation by 3, 0. 3, 0 means 3 units to the right. This means fx minus 3. Second type of transformation, reflection. Reflection, we have reflection on x-axis and reflection on y-axis. Reflection on x-axis, if we have y equal negative fx, y equal negative fx, this will be reflection on x-axis. So if we multiply y by negative, this will be reflection on x-axis. If we have y equal f negative x, negative x in bracket, this means reflection on y-axis. For example, if we have y equal root x, the same function. If we find the reflection on, I need to find y, to draw y, sketch y equal negative root x. So just reflection on x-axis. So the same. So if we have negative, if we multiply the function by negative, this means reflection on x-axis. Second type, reflection on y-axis, if each x represented by negative x. This f negative x, not negative fx. If we need to find f negative x, this will be reflection on y-axis, mirror line. This is the function y equal root x, and this is the function y equal square root of negative x. Reflection, mirror y-axis, the reflection on y-axis. Stretch, the last type of transformation, stretch. Stretch, if we multiply the function by 2, we have the original function y equal fx, and we multiply this function by 2. What is the effect on the sketch? If you multiply by 2, so away, the new curve will be away from the x-axis. Move away from the x-axis. The points will move away from the x-axis. And we will see, for example, if we have y equal sine x and y equal 2 sine x. If we compare between them, look, if we have y equal sine x, this y equal sine x. The maximum 1 and the negative, this y equal sine x. What about if we have 2 sine x? If we multiply this function by 2. Now the maximum will be 2 and the minimum will be negative 2. So look for the point. The point move away from the x-axis. Move away from the x-axis. The point, the same value for x, but the y will be greater. So move away from x-axis. So this is called vertical change, vertical stretch. Move away from x-axis. If we multiply by half, this move towards x-axis. For example, if we have sine x and we multiply by half, we get this function. The new function will be closer to x-axis, because the maximum will be half and the minimum will be negative half. So like the points move towards x-axis. The first one, y equal f2 2fx, the point xy will be x and 2y. For the second y equal half fx, the point xy will be x and half y. Y equal f2x, If we multiply x by 2, the inner, if we multiply x by 2, I will replace the x by 2x. This will be towards y-axis. Towards the curve will move towards y-axis. Towards the y-axis. And for example, if we have sine 2x, y equals sine 2x. Sine 2x, if we draw sine 2x, this point, the period will be 180. So look for this curve will be, this will be like move towards y-axis, like the points will be closer to y-axis, and each point xy will be x over 2 and y. So if you multiply x by 2, the new points will be divided by 2. Multiply by 2, divide by 2. Opposite, do the opposite. If you change the inner, which is x, if you multiply x by 2, you should divide x by 2. So the new point, xy, will be x over 2 and y. If y equal fx, y equal if half x. In this case, if we multiply by half, you should multiply by 2. Multiply by half, then multiply by 2. And the curve will be away from the y-axis. Away from y-axis. Examples for stretch. Look for y equal root x. This is the original one. And if you multiply by 2, y equal 2 root x. Look for the points. The first point 1 and 1 becomes 1 and 2. Second point 4 and 2 becomes 4 and 4. So the points move away from x-axis. Stretch away from x-axis. Like the points move up, move away from x-axis. 1 1 becomes 1 2. 4 2 becomes 4 and 4. So if you multiply by 2, the point stretch away from x-axis. And the point x the same, x the same, but y multiply by 2. But if we multiply by half, we have the original function y equal. If we multiply by half, number between 0 and 1, if we multiply by number between 0 and 1, the points will be closer to x-axis, shrink to x-axis. So the point 1 and 1 becomes 1 and half. The point 4 and 2 becomes 4 and 1. 4 and 2 becomes 4 and 1. So the points move towards x-axis or shrink to x-axis. Shrink to x-axis. X the same, but y multiply by half. X the same, but y multiply by half. If the original function y equal root x and we multiply x by 2, multiply x, not root x. Multiply x, we switch x to 2x. In this case, the new points will be x divided by 2. Do the opposite. X divided by 2 and y. So what happened for the original look? This is the original sketch. The original function. If we multiply x by 2, we get this one. So what's happened? Point 1 and 2 and the point 4 and 2. Look for the points. The curve will be close to y-axis. Will be closer to y-axis because shrink to y-axis. Shrink to y-axis because the point x divided by 2. X divided by 2. So x will be closer to y-axis. And look for this one. 1 and 1 becomes half and 1. Becomes half and 1. So the point be closer to y-axis. Closer to y-axis. So shrink to y-axis. Because if you multiply x by 2, for the new point will be x divided by 2. So the point will be x over 2 and y. X over 2 and y. So the point in this transformation, the point x and y will be x over 2 and y. So the point will be closer to y-axis, shrink to y-axis. The last one, if we have y equal root x, what about y equal square root 1/3 x? In this case, if you multiply x by 1 over 3, you should multiply x by 3. So the point 1 and 1, the point 1 and 1 will be 3 and 1. So x multiply by 3. X multiply by 3. So if you multiply x by 3 and the y is the same, so this means the point will be away from the x-axis, stretch away from the x-axis, from the y-axis, stretch away from y-axis. So the point, if you have point x and y, this point will be 3x and y. So if you multiply x by 3, this will be away from the y-axis, move away from the y-axis. So this is called horizontal stretch.